All right, let's talk about something that's kind of the unsung hero of the digital world. It's not the super neat, rigid database you might be picturing, but it's also not just a chaotic mess of text. Nope. It's this flexible middle ground called semi-structured data. And trust me, getting a handle on this is key to understanding how pretty much all modern information gets exchanged. So let's dive right in. Okay, so here's the game plan for today. We're going to start with a pretty common problem, a real dilemma in how we handle information. Then we'll get into the really cool solution, semi-structured data. We'll meet its most famous player, XML, figure out how to actually find stuff inside it, and then at the end, we'll see how it compares to the old school databases. All right, so let's set the stage here. For the longest time, the world of data has basically been split between two very different extremes. Just think about it like this. Is the data you deal with all neat and tidy, perfectly organized in rows and columns, like a spreadsheet? Or is it more like a messy notebook, just kind of free-flowing, full of notes, ideas, random paragraphs? That right there, that's the core dilemma we're talking about. So on one side, you've got structured data. This is the world of relational databases. Everything has its place, right? The rules, what we call the schema, are totally set in stone. It's super predictable, sure, but man, it is hard to change. Then, on the complete other side of the spectrum, you have unstructured data. Just think of a novel or a web page. It's a total free-for-all. You, the human, have to actually read through it to figure out what's what. But what if you need the best of both worlds, right? What if you need something that's organized, but not totally rigid, something descriptive, but not just chaotic? Well, this is where a much more elegant solution comes into play. And that solution is semi-structured data. It's really this brilliant compromise between those two extremes we just talked about. I mean, it has organization, but that organization is flexible. And here's the really crucial part. It's also self-describing. So what on earth does that actually mean? Well, self-describing basically means the data itself tells you what it is. Seriously. Imagine a file cabinet where every single document has its own label, perfectly explaining what's inside. You don't need some separate giant instruction manual to figure out the system because all the information about the structure is baked right into the data itself. Pretty cool, huh? And this brings us right to the star of today's show, XML. It stands for Extensible Markup Language, and it's really the classic go-to example of semi-structured data in action. Now, to really get why XML was such a breakthrough, we kind of have to look at its cousin, HTML. So in a normal HTML bibliography, you've got these tags, right? Like H1 for a heading or I for italics. The thing is, they only describe how the text should look. They mix the what, the actual content, with the how, the presentation. And if a computer program is trying to find, say, just the author's name, well, good luck. It would have a really tough time sifting through all that visual clutter. Okay, but now, look at how XML solves this. The tags here don't say, make this big, or make this italic. No, they say, this is a book, this is a title, this is an author. See what's happening? XML cleanly separates the meaning of the data from how it's displayed. And just like that, boom, the structure is suddenly crystal clear, not just to us humans, but to machines too. And that is the magic of XML. It's a text-based format designed for one thing and one thing only, describing the content of the data. The structure itself is just defined by the names you give your tags and how you nest them inside each other, creating this really meaningful, tree-like structure. And you know what? This design gives it some incredible advantages. First, because it's just plain text, it's totally portable. You can use it on any system. It's also super flexible, so you can represent pretty much any kind of information you can think of. And it's extensible. What's that mean? Well, if you need to add a new piece of info, you just add a new tag. That's it. No need to go and redesign an entire database from scratch. Okay, so we've got our data all neatly structured in XML. That's awesome. But how do we actually find what we're looking for? How do we pull out the specific pieces of information we need? All right, let's jump back to our bibliography example for a second. And just imagine this document is way, way bigger, with maybe hundreds of books in. So here's the question for you. How would you write a command to pull out only the titles of every single book in that file? Well, you use something called XPath. And this is where the power of XML's structure really, really shines. Look at this. An XPath query looks just like a file path on your computer. It's that simple. You're literally just saying, hey, start at the very beginning, go into the bibliography element, then look inside every book element, and just give me what's inside the title element. It's such an intuitive, easy way to navigate and grab the exact data you need. All right, so for our last piece here, let's zoom out a bit. Let's put all this together and do a head-to-head comparison between the flexible world of XML and the rigid world of traditional databases.
Yeah, this table really sums it all up, doesn't it? With relational data, you've got that rigid, fixed schema you have to decide on in advance. With XML, nope, it's totally flexible. Relational data is all about those simple, flat tables. XML, as we've seen, is all about that nested tree-like structure. And this last one is so important. XML was designed from day one to make sharing data between different systems easy. And that was a massive headache for traditional databases.
You know, when you boil it all down, it really comes down to this one idea. We live in a world where information is constantly changing, constantly evolving, especially on the web. And when that's your reality, a system that can adapt easily isn't just nice to have, it's incredibly powerful. That flexibility, that's the greatest strength of semi-structured data.
So, I'll just leave you with this to chew on. In a world that's creating more and more complex data every single second, what's more valuable for our future? Is it the absolute rock-solid predictability of a rigid system? Or is it the adaptive, evolutionary power of a flexible one? Something to think about. Thanks for joining me.